First thing, what's the first law of test management? I'm starting 12 minutes late. Do I get to finish 12 minutes later too? Right. I want to talk to you about some work I've been doing over a couple of years now, I'm guessing. And it's to do with how we think as testers. So I want to sort of describe, if you like, it's like a research project in some respects, but it's also what I think and believe are the most fundamental thought processes of how we test. Now, interestingly for me, is that I'm not a psychologist, I'm not a brain surgeon or anything like that. This is all speculation, but I'm going to offer a model which is wrong. All models are wrong. Some models are useful. So I want to offer something for you to think about, and the reason I'm kind of confident that I'll make you think a little bit more clearly about how you offer your testing services is that I've never been challenged on it. No one has ever said, that's wrong. Not even Mr. Bach and Mr. Bolton. They quite like it, I'm told. So I challenge you, if you think it's wrong, please come and grab me at the end, or ask a good question and I'll try and offer a solution to it. Before I do anything else, I need a drink. Okay, oops, that's not working. Yes, it is. Excellent, right. So I need to sort of start and kick off the whole talk by suggesting that the way we've tested in the past will not work very well in the future. And my argument for this is that what Agile has done is it's made us sort of step back and question our thinking about how we build software, of course, but also how we test. And we're moving away very steadily as a whole industry from large-scale, planned, designed, staged approaches and moving towards a more dynamic approach. Now, I want to talk about sort of methodology for a few minutes shortly, but I run an event in the UK which was aimed at test managers, and it started in 2004, so it's been going 13 years or so. And I must have had 100 people come and approach me and say, Paul, I've been agiled. You know, it's a transitive verb, okay? So to be agiled, there's an object, okay? And it's not something you do, it is done to you. And for a lot of testers and test managers in the early days of Agile, let's say 7, 8, 9, 10 years ago, testers did not know where they fitted. They didn't know what their role was because Kent Beck's book didn't really suggest a role for the testers. It just kind of happened. They kind of helped with the users, the user testing. And that was it. Now, collaboration approaches like BDD have helped because now we have a slightly better defined role for testers in the three amigos. You know, the user or BA, the developer, and the tester, these are the three amigos. This is the collaborative team that assesses and understands and analyzes and then constructs stories which define the behavior of the software, okay? So BDD has helped a lot. But now we're seeing increasingly things like continuous delivery, DevOps, the whole digital experience. Is everybody working on digital here? Is digital a big deal in Hungary? How many people are working on digital? None. I can see a few hands, okay. In the UK, if you're not working on a digital project, you're not working, okay? It's taken over everything. And I think in America, it's a similar kind of process is taking place. What I'm trying to say is the whole notion of migration from paper-based systems, systems of engagement which are not mobile. We're moving everything into the mobile space. We're bringing in artificial intelligence, machine learning, that kind of stuff. We're looking at Internet of Things, which is not taking off, it's not exploding, but very steadily it's getting bigger and bigger. Things like robots, you know, physical robots and bots, software bots, are increasingly used behind the scenes, working on data that we never see as individuals, as consumers of services and products in the marketplace. Now, what is happening, I think now, is that the move towards DevOps is something that will take, like Agile, a long time. So Agile started in about 2000. So it's now 2017, and we're not halfway yet. Are we? I don't think we're halfway. With continuous delivery in DevOps, I think the process of adoption will be much faster, and I'll try and explain that in a moment. At any rate, if your processes are changing almost every week or every month or every quarter even, you have to readapt to how you test in a new environment. Okay? And in order to do that, we need to be able to be flexible as testers. Now, if we're encumbered and we're weighed down by all the crap we have to deal with, some of which that Lloyd was talking about a bit earlier, it's going to be very difficult for us to adapt, to move, to shift left, to look at automation as a solution to some problems. So my argument for this whole idea of a new model is that I think in the future, change is just going to get worse for us. Okay? That's my argument. So we'll need a new way of thinking, or at least we'll need a new way of thinking about testing. And it also drives out some interesting proposals for software tools that support testers as well. So I want to suggest that the model is there to help us understand what we do, and by understanding what we do better and the way we think better, we're able to be adaptable in the future, which is a good thing. Okay? So let me just talk about process for a little while. It's kind of boring, but you might find it interesting. We'll see. We'll see. Now, most people have been encouraged to move away from waterfall, structured approaches to Agile. Now, what I want to talk about is this notion of waterfall, structured, the old way, Agile, maybe the new way, but where does continuous delivery and DevOps fit? I think it's a third way. It's not Agile. It's very different from Agile, okay? And I'll try and show you why I think that. And by understanding that, I think then you'll be able to assimilate what's coming at you and understand the challenges that are coming at you when people say, yes, 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 you're shifting left. Left. Or what we're going to do is we're going to automate all the testing. Or we're going to use bots to make some decisions in our software development processes, not testers anymore. Or whatever, okay? This is where I'm coming from. So let me just walk you through another model. If you were in my session on Monday, you know I'm obsessed by models. It's crazy, but there you go. So we have one approach, which is the structured, waterfall, staged, phased, maybe the old way, big project way, whatever. We have Agile, you will understand, I'm sure. And I'm suggesting continuous is different. There are commonalities between the three. So we know that structured and Agile have a goal. You know, they have a target, if you like, to aim at, a target solution. We know that Agile teams and continuous delivery teams, DevOps, are autonomous. You know, managers give them authority to make decisions in their processes. But by the same token, structured and continuous are very high process. And you might say, hold on, continuous is all about tools. Well, hold on. If you want a tool to implement a process, it had better be well defined. Because a tool is going to follow it to the absolute letter, to the absolute bit and byte. Okay? So there is as much commonality between structured approaches, disciplined approaches, and continuous and DevOps, as there is between Agile and DevOps. So I think it's a third way. So let me just illustrate that and try and explain and define that, because if you look at the characteristics of the three approaches, I've picked out these. You could do it yourself, you know, and you might put different information in these fields, but I've identified, 8 characteristics. I'm sure there's more. I could have done 20, I guess, if I'd thought about this a bit more deeply. But I looked at the structure of teams, the pace of delivery, the cadence, if you like, leadership, the definition of the requirement, and so on, okay? So these are my 8 characteristics I'm going to look at in the 3 types. I am generalizing. I understand you might do it differently. I appreciate that, okay? So let me just say, I'm generalizing. I'm guilty, okay? So this is the picture I came up with. So we have these 3 approaches: structured, agile, continuous, stroke, DevOps. Let me just pick out 2 or 3 of these. What's interesting? Leadership. So in a waterfall project, there's a project manager, a head, who runs the whole project. In Agile, it's a bit like guided research. You could say it's the product owner, or maybe there's a product manager who has oversight, but it's not clear what the outcome will be. You know, you don't know where the Agile team will actually get to. Okay? It's unpredictable. It's like a research project. It might not deliver what you want in the time you want it. The leadership in a DevOps continuous delivery team is line managed. It's almost like a factory process. It's not as brutal as a factory, but it's like a line management role. With testing, again, generalizing, scripted, exploratory, automated. Our expectation in continuous delivery is we automate as much of the testing as is visible almost. So we don't delay the flow through the development pipeline. One more. Automation. In a structured project, the tendency was to create the automated tests after all the testing is finished. Because now we know all the tests pass, let's automate what we've got, that's our regression test pack. That tended to be the way it works. With Agile, it tends to be develop-led. So if they're doing TDD or even BDD, a lot of the automation, perhaps all the automation in an Agile project is developer-driven. With continuous and DevOps, it's pervasive. It's all over the place, all the testing. Once the button is pressed for a commit to deploy, all the processes are automated, or as many are automated as you can possibly make. One last one, measurement. In structured, it's pervasive. Everything gets measured. You know, timesheets, you know, deliveries, it's whatever. In Agile, it's avoided. The whole no estimates meme. It's like, don't ask me for an estimate. I'm not any good at that. Just give me the space and time to build what I think you need to build. I need to build. But whereas in DevOps continuous, it's analytics. Because we have automated processes, the measurements come from the tools directly. It's pervasive, like the automation. So that's kind of the shape of the three styles. So I've tried to make a case to say Agile, waterfall, continuous are different approaches. And I've said there are three approaches, but you know what? There aren't. No one does it like that. No one does Agile properly, apart from a very small percentage, I think. Most people do Agile, but we have requirements documents. Agile, but we have major deliveries every 3 months. Agile, but we don't have an on-site customer, we meet him every 3 weeks. Agile, but whatever. Everyone does some form of hybrid. And this is my argument for saying, because the way you work in your company is not as it is in a textbook or from a consultant or from me, you have to figure out your own way of acting as a tester in that environment. Okay? So I use this as an argument for saying, let's step back and understand how we do and what we do and how we do it better, and then use that knowledge to be adaptable. Okay? Let us understand our skills much better before we make a commitment to document our test or to automate our tests or to not automate at all. We need to understand that. So what I'm really trying to say is it's a continuum. There's no one way, there's not 3 ways, there's 3 billion ways. Now we know where we stand. And you might say, I'm terrified. I don't know, maybe not. But what I'm trying to suggest is that if we do understand how we work better, we can adapt more appropriately. That's really what I'm trying to do here. So in a way, what I'm trying to suggest is, rather than having a process given to us, we have like a do-it-yourself process. To be truly agile, every morning in your stand-up, it's a reasonable question to say, how will we work today? Should we be a bit structured today? Should we be a bit continuous delivery? Or should we just sort of ask the developers to do whatever the hell they can in the next 6 hours? I don't care. It's a do-it-yourself process. I think we're going to move more and more towards fully autonomous teams, okay, who decide how they work almost on a daily basis. Now, you wouldn't change the way you work every day, of course not, but you have the possibility of doing that, and that's what agility really, really is. So, okay, I've said enough. That's my intro. And I need more alcohol. Not yet. So we need a new way of thinking, a new model of thinking, a new picture which says this is how we work, free from logistics. And I'll explain what logistics are. Logistics is all the crap we have to deal with, okay? So that's my very broad brush. but I'll give you some examples. Before I do that, I want to talk about modelling for a moment. So we have this handsome fellow over here, and he's thirsty, and he's going to walk across to the desk over there because he wants to drink some water. In order for my body to make its way, to traverse, to walk from here to there, my brain has to understand the configuration of about 100 bones, the big bones in my body. Okay? It has to understand the angles of all the joints. Okay? It has to understand the tensions in the muscles, how much pulling it does. And in order to take a few steps from here to there, my brain has to send nerve impulses to about 100 muscles at once. 100 muscles every second. But actually, much faster than that. If you look at how the robots, like the Boston Dynamics robots, these four-legged and two-legged robots operate now, they're incredible, but they have massive processing power. We don't have that. We do it a different way. Somehow, and no one knows yet, no one knows, somehow our brain models a complex problem and simplifies it through modeling. So what our brain does is it creates a model of the world, of the structures it's got to encounter. It plots a trajectory from here to there. It starts sending nerve impulses to these 100 muscles, and I can take a few steps, and I can pick up my glass of water and drink it. That's incredible. And it's all possible because our brain can model. We are modeling engines, okay, with superpowers. Again, as Lloyd says, we have superpowers. If you compare what we can do with what the robots can do, we are still much more efficient. So modeling is innate, essential human. Modeling makes humans what they are, almost, okay? Now, I'm not a psychologist, I'm not a brain surgeon, I'm not none of these things. I don't know what I'm talking about. But these things must exist. If we don't use pure processing power, we must have a pretty good formula up here, a model, which we use to direct all this traffic to our muscles and to keep going in a straight line and not to fall off the stage. Isn't that clever? That's how good our brains are. So let's make use of that capability. So in what I say now, in the next few minutes, when I say model, you could substitute the word understanding. We understand complexity through modeling. My model in here is my understanding. Okay? So, sources of knowledge. So, okay, so when we're in any kind of project you care to name, we have to maybe read requirements documents. We have to talk to users. We might create stories. We might put diagrams on whiteboards. We might have fantastic pictures, state transition diagrams, logic models, whatever. All these sources of information, the tester has to kind of collate and understand, analyze, do the clever stuff, and come up with an understanding of what the requirement actually is. Sometimes these requirements conflict. Two users might want slightly different things, and we have to almost act as a referee and say, well, who's right? You know, is it the boss, or is it the guy who knows what he's talking about? That kind of thing. We get our information through documentation, we get it through interviews, verbally, we get it through our own experience. I know what a sales order processing system does. Okay, I understand the process of placing orders. It might be that I have experience of similar systems or the exact same system, the old system. It might be I have prejudices and biases and misunderstandings, and I don't actually know what I think I know. All this stuff is what goes into our heads that we have to make sense of, that we have to understand, and once we understand, we think, aha, I can test now because I understand what this system should do. This is a remarkable thing. This is what our brains are doing. So to date, and in waterfall projects, requirements dominated proceedings. Requirements were everything, weren't they? We always tested against requirements. Even though we knew they were wrong, they were out of date, they didn't give enough detail, blah, 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 blah. So Agile came along, and then we've just shifted the problem slightly to the right by saying, well, let's write user stories, which are a bit more detailed, and if you're into BDD, cucumber, and gherkin, the formal language, we get examples built into our requirement, which is great. That's exactly what we need. I agree. So what we've tended to do in the past is trying to define a system to perfection. What we're moving towards is to treat it as an emergent solution. We don't know how our understanding is going to evolve, but it is going to change over time. It is going to evolve. And we're moving towards a place where our processes are going to cope with that. That's continuous delivery. So, right, now, after that huge build-up, this is how I'm going to play it. In order to understand how we think, you have to free your mind, okay? So it's a bit like Neo in The Matrix, when he's trying to jump over the tall building, like that. And he's there going, saying, free your mind, free your mind. This is what we're going to do, okay? Or I'm going to do in front of you, okay, remarkably. So this is how I'm going to play it. I'm going to say, forget logistics. And this is how I'll put it. I do not care whether you document your test or not. That's logistics. It's not testing. That's just writing stuff down. That's not testing. I don't care whether you run a test by hand or use a tool or use some other piece of magic. I don't care. That's not testing. That's a piece of logistics. I don't care whether you're working in an Agile or waterfall or continuous delivery or some new process no one's ever heard of yet. That's logistics. The process is logistics. Okay, the physical process. I don't care whether you're in banking or telecoms or healthcare or government. Not relevant. Doesn't matter. I don't care what technology you're using. Whether you're working a good old mainframe right through to the snazziest mobile applications. It's not relevant. It doesn't affect the way we think. Okay? Trust me. Now, you might think, hold on, if I get rid of all these logistical things, what's left? Oh, I've got a blank page now. Well, there's nothing to think about. Well, I think what's left is your thought process for testing. Okay? That's what I'm trying to do. So, let me now say, right, we've got a clean piece of paper now. Let's build up what we do. And here it is. All testing is exploratory. Okay, all testing is exploratory. I think Michael Bolton is now saying this. We're dropping the exploratory word. Or it might be James as well. So I think what you'll see in the next few years, the word exploratory will disappear from our lexicon. All testing is just testing. All testing is exploratory. Let me explain. What we do as testers is we explore our sources of information. We read, we interview, we have meetings, we think, we look at the old system, and if the new system's available, we look at the new system. These are all sources of information. We explore all that input. We build models. You could call them test models. You could call it understanding. I don't care. We build understanding through modeling in our heads. And at some moment, we think, you know what? I understand what this software should do. Now, I can test. So what our model does is it supports our thinking. It provides us with an information, a roadmap, if you like, almost, of how we create tests and test our software. Okay? So we explore our source of information, we build our models, build our understanding, and then we're ready to test. That's how it works. It's not very complicated. So that's from the top of the mountain. Let me go halfway down and just break it up a little piece. We have this notion of exploration on the left, your left, and we have our sources, and we create our models. And at some point, we think our models are okay, our understanding is adequate, it's enough, I trust it, and we go on the right. And then we test. And what happens when we test? We discover things that, it's more complicated, isn't it? Or, hey, there's a piece missing. I've got these 3 features, but what happened to the delete option, for example? Or I find bugs, and all sorts of other things come to light, okay? I discover stuff. So I might have to go back to the left and say, Mr. User, have you thought about this situation? Yeah, you're right. Okay, yeah, let's add a delete feature. Okay? And then we go back around the loop. Okay? So we have this kind of loop. We want to be on the right. We want to be on the right. But sometimes we have to go back to the left. And in the middle of all this is this green blob called judgement. And I can't explain what's in that green blob, except I know it's there. We all have to make these judgments about whether we understand well enough. We all do this, I think. Or we ask our boss, or we ask our colleagues, what do you think? Do we know enough to go further? Can we create tests yet? Okay? So that's the halfway down position. And this is a good point to sort of say, do developers think this way? Well, I think they do. Because developers have the same sources of knowledge that you have. They have to build mental models in order to write their code. They have to build mental models to test their code. They might create different models. In fact, they probably will create different models from the tester. But they're going through the same thought process. Okay? Their outcome at the end is tested software. Well, hold on, forget the software, it's just some tests that have been run. The outcome is very similar to what we do. So in the situation where you're being asked to shift left, I think it might be helpful to have this conversation about, well, how do you work out what to do next in your development process, in your mind? How do you do that? Have that conversation, because I'm going to show you the detail now. We're now at the bottom of the mountain. So on the left, we have our source of information. Okay, you know what it can be, almost anything. We ask questions, we read, we interview, we debate, and we build our models. Okay? And when we have our model, when we understand what the system should do, we can make predictions. We can say, well, if I input A, B, and C, then the system should do D, E, and F. I can make predictions. And when I can make predictions, I've got this fantastic opportunity to go back to my sources of knowledge and say, if I put A, B, and C in, then D, E, and F should happen. I can challenge my sources. Mr. User, are you happy with this? And what will the user say? That's exactly correct, Paul. Well done. Or they might say, oh shit, that's not what it should happen at all. Or something in between. Sometimes we can discover massive problems just by asking the question, is this how it should work? If we ask it early enough, the thinking can be done to refine the requirement and implement a better solution. We have massive value by looking at these activities on the left. So this is the process. We inquire, we gather information, we model, we make predictions, and we use those predictions to ask awkward questions of our stakeholders. So, okay, but at some point we're happy, we understand. So now I've got my model. I think I understand. It informs my tests. Maybe my model is a flow chart, or a state transition diagram, or it's a checklist of things to look at. I don't care, that's logistics. I can apply my tests. And I use the word apply, not run or execute or whatever. I use apply because I don't care how you run this test. Manual, automated, don't care. When we run the test, we can interpret the outcomes. So applying includes the checking for correctness, pass-fail. Interpreting says, well, I've run 50 tests, 48 pass, 2 fail. What does that tell me? That's where the human interpretation comes in. Maybe a tool can do all the applying, but right now, people will make the interpretation. When we interpret, it might be, you know what, there's a bug. So this isn't part of my model, but it's just to let you know that I'm not completely going to the moon or anything. So I log bugs, I fix the system, and I go around the loop again and retest, okay? When I run my tests, I report, fair enough. But I also might discover my model is flawed. We need some more tests because it's a bit more complicated. Or we're finding some bugs in this area, we should go into a bit more detail and refine our model. We go back around the loop again. Sometimes we discover, you know what, we've got a real problem here. We've misunderstood the requirement, or the developers have got it completely wrong. We need to step back and understand what we should do next. You need to go back to more exploring. When you glue it all together, this is what it looks like. And it kind of looks like a bug. That wasn't the intention. It just happens to do that. And that's why I'm calling it a new model, okay? So these 10 activities, inquiring, modeling, informing, reporting, and so on, these are the 10 major thought processes we go through as a tester, without any reference to logistics. I think everybody does this. So, because it's a keynote, I can't sort of have a little debate now about whether you like it or hate it or anything in between. let's talk afterwards if you're still here. But that's it. So creating a model is one thing. What is it useful for? Okay? If it's not useful, it's useless. And therefore, it's an academic activity, it's of no value, throw it away. Unless I can use it for something, it has no value. So the first thing is I spent 2 hours talking about that and how modeling is at the core of what we do. Okay? I can't spend 2 hours now doing that tutorial again. But understanding how models are at the center of what we do is the most important thing we can do as testers. We have to understand modeling is our primary skill. It's the first skill. Okay? So that's the first thing that I think it's useful for. And now I'm going to talk about some other stuff, right? So let me talk about skills. So if the model is correct, let's imagine, speculate that. Here are my 10 activities. So what I'm going to do is show you some skills. And this is not researched with 10 years experience and thousands of user reports and all the statistics and analysis. No, this is speculative. This is my guess of the kind of skills we need in order to satisfy the needs of those 10 thinking activities. And it looks something like this. And I could add a few, knock a few out, I don't care, whatever. Let me look at them for a second. So which ones do I like? So I like predicate, logic, and proof. Understanding how language makes propositions that are logically sound. Predicate logic is about understanding text. It's pretty fundamental. Can I ask, how many people have done a predicate logic course? I think I'm getting 2 or 3 hands, okay? The rest of you, buy a book, okay? Or go on a class. You will find it remarkable, it'll uplift you. Now, the guys who've done a class 20 years ago at college or whatever it is will probably have to revise. But it's fundamental to what we do as testers. To be critical of requirements is to know how to analyze a sentence. That's what predicate logic gives you. Next one, hypothesis and inference. That's modeling. In effect, that's modeling. As we played in the little toy programs we had on Monday, you're learning by playing. And you're building your mental models, you're understanding with a view to understanding what a piece of software does. We build hypotheses, our model, and then we try and use it to prove it, to demonstrate. We test it, we test our hypotheses. This is part of our understanding, okay? Again, Lloyd sort of said, what happens if? What happens if I put in A, B, C? Well, is it D, E, F, or something else? That's hypothesis and inference. The next one, and then I'll stop doing this, the Socratic method. I'm sure you've all heard of Socrates. Has anyone studied the Socratic method? No lawyers in here. Be like a lawyer in a courtroom. So there's some guy and he's up for murder in court, right? And you have the defender and the prosecutor. And both of them are professionals. They're professional question masters, aren't they? The questions they ask, they always know the answers to. Well, sir, were you at this place at this time in the vicinity of da-da-da? Yes, my lord. Yes, I was. And were you found holding a knife with the blood in your hand, fingerprints all over it? Yes, my lord. Well, I submit this guy is guilty. You ask questions you know the answers to. So when you model the requirement and you can make predictions, and you use that prediction to challenge, you say, well, if I put in A, B, C, then I think D, E, F should come out. Is that correct? Oh, shit. And you knew he was going to say that because it's clearly inconsistent. But you have to give them that evidence, that opportunity to think for themselves. If you say the requirements are poor, you never make progress. Because we all know requirements are poor. If you want them to change, you've got to give them an example of saying, you will look like an idiot if I tell people I showed you this evidence and you ignored it. Now, you might still get fired for that, okay? Hopefully not. But I think you can help your projects by being this kind of intelligent agent rather than submissive and just saying, requirements are always bad, I just test against bad requirements, that's life. I think we could do so much better than that. So these skills here are what I think are the critical skills. And there's some obvious ones like critical thinking and interpersonal skills, the ability to work with other people and communicate well. So with a friend of mine, Susan, we put together this very, again, speculative, how might this look as a structure for like a career development path? You know, what might the qualification scheme look like? Okay? And I'm not going to spend any time on this except to say, I think most of the certification stuff goes there on the right. Now what's interesting, which I didn't realize until I looked again at the table of contents for the certification schemes, is that, do you remember all that stuff I said I don't care about? Most of it is in the certification scheme syllabus. And I'm not going to make any argument about that, it's a fact. Look it up. Look it up. Okay? So, I need a drink. Need more tonic in that. Test automation is logistics. Running tests with tools is logistics. Building environments, constructing test data, shutting things down, doing comparisons, all that stuff that we need to do in our test execution processes is logistics, okay? And I will argue ahead of time, I'll say this a bit later, but we don't need more test execution tools. There are hundreds, I can tell you, there are hundreds doing everything we'll ever want. What we don't have are thinking tools, tools that support our thinking, not do our thinking, but helping us to think. So I would say that test execution tools, test automation, fits there in applying. It only covers one of the 10 thought processes. The rest of them were very, very badly supported by the tool vendors. Should I blame the tool vendors for this? Or should I blame you? I think the tool vendors build the tools they want to give you. They don't build the tools that you need. And I'm arguing that you guys need to argue with those guys and saying, where are the tools that help me to do the really important stuff? There's one tool vendor out there which does model-based testing, which is definitely moving to the left, building model making and using models in that way. I won't name them, and there's 2 or 3 across Europe. There's one in Israel, I know. There's definitely one in the UK. There's a global corporation doing one as well. I'm not going to name anybody, okay? But they're coming. Thank God, 25 years late, I would say, but thank God for that. So let me look a bit more closely at what automation does and does badly for us. If you imagine test automation is trying to sort of say, has this bridge moved? Okay? So when I make a change, has this building shifted position? You know, I need a surveyor, I need a laser theodolite or a level to measure to the millimeter how much stuff is moving. Now, if you compare that to software systems, it's a bit like this, isn't it? I don't need a theodolite or a laser level to see the variation and the change day by day. And yet that's what we're trying to use tools to do. They are hypersensitive and they're precision tools. But we're looking at things that don't take any precision at all, okay? And the problem is, our thinking as testers is not aligned with what's going on in the development team, because we're using a different model, I would argue. So, test execution automation, my argument is it's a modeling problem, not a tools problem, okay? Yes, tools have bugs and tools don't always work the way you want them to. Yeah, I get that. But half the problem, maybe more than half the problem we have with test execution automation is that we're using a different mental model. So let me explore that. So this is not the best diagram I've ever drawn, but we'll see. See how I get on with it, because I've not used it before. If you imagine all the new code, week by week, is in red, okay? And each column, each vertical, is, say, a weekly release or a monthly release, whatever you like. So every week, we get some new functionality in red, which we test. So the first week, we just have red, a red dot. We test it, and then we release it, and then off we go. The week after, we have one black dot. We have some old software, which we retest, and then we have some new software, red, which we test for the first time. And week after week after week after week, the amount of software our teams are generating, the red dot, is static. The amount of software that we have to regression test and manage for consistency gets bigger. It's not a straight line. It's not always growing. I know we have changes and all that other complication stuff. But essentially, there's software that's new and there's software that is not new. The software that is new, typically, we manually test. That is, we explore, we just test with people. But at some point, when you have tested that software, you hand off to the test automation. But the tests you run for new functionality probably are not the tests you should be applying through automation. And let me explain that. I think I've said that. The goals of the two types of testing are different. It's not the same. It's not the same. Let me explain. Here we go. When we test new functionality, our goal is to demonstrate some requirement is met. That's what we're trying to achieve. I run some tests, and you know what? The software should do A, B, C, and great, it does A, B, C. If we find bugs, we fix it, yeah. But ultimately, we want to demonstrate it does what we want. The purpose, the goal of regression testing is not to ask whether it works correctly. That's not the question. The question is, does it work the same way today as it did yesterday or last week? We're looking to demonstrate functional equivalence. Does it behave the same way? We've tested it in the past and it worked. Now let's see whether it works the same way, week in, week out. So that is a different goal. That is a different objective for our scripted testing, for our automated testing. Okay? Now, I understand that you might want to keep your most important tests and say, well, we should automate these because they're so valuable. They provide so much value. Okay, that's cool. That's all right. But the fundamental goal is to demonstrate no side effects of new software. Okay? I think that's the biggest thing we can learn about. That's what I'm bringing to the party right now. It's the biggest thing I think we can do. The biggest change you can make in your thinking with automation is to stop thinking, I've just got to rerun my functional tasks, because they might not be very easy to run. And yet, some simple automation from the developers, testing web services, hundreds and thousands of times, that can be done with tools, and it can be done very easily. Why the hell waste people's time? So functional equivalence is about demonstrating version N does the same as version N-1. And the thing really is that we need to be on the same wavelength, not as our users for regression, but as our developers. So if they're creating test automation because they're doing TDD, that is the most valuable regression testing you've got. They know if they make a change to a module and their TDD tests fail, they've got to fix them. So people later on are almost unaffected. We don't need to test later on, perhaps, potentially. Okay? But that's the message, that the goal of regression testing is not the same, the model is different, our tests should be different, and I believe can be simpler. Can be simpler. Okay. So the next question I want to look at, after another drink, sorry about this, is if we're moving to continuous delivery, DevOps, all this kind of new world stuff, there's automation everywhere. It's pervasive. It's everywhere. Now, in order for this pervasive automation to operate, we don't have manual steps in between all the automated processes. We either hand off and things just happen, or we have some automated intelligence, a bot, to make decisions on our behalf. So how do we trust what these bots do? And that's what I want to talk about in the next few minutes. So I asked a friend of mine, Rob Lambert, a year or two ago now. I said, Rob, you're doing DevOps. He was doing it 2 years ago and really giving presentations, 3 years ago, giving presentations about what a wonderful world it was compared with the nasty old world. How many tools do you use, Rob? And he sent me an email and he made a list. And I'm going to speed this up if you don't mind. 23. Is that more than you guys use, or is it about right, or a lot less? Does anyone use 50 tools? 40 tools? There's a hand there. Are you scratching your chin? It's a lot. Most of these tools, the testers have some kind of interface with, so some sort of relationship with. They either use them or provide data for them, or they take data away from them. That's the world we're moving towards. Pervasive automation. But most of these are to do with the logistics, not thinking, all right? So this is how I categorize tools in the whole DevOps. I'm looking more closely at collaboration, DevOps, testing, those three areas. That's my kind of architecture of how the tools can be classified. There are other ways of looking at this, but that's mine. And a little plug, I run a website called tkbase.com, which is a directory of tools in that area. There's actually 2,400 and something tools in there. But you didn't know there were that many tools. But about 700 of them are programming languages. So take the programming languages away, you've got about 1,800. Suggest you take a look. I'd be very interested in feedback. So, okay, so if we have automation doing all this work, and we have bots making decisions, taking us through the pipeline, how do we trust them? Now, how can we trust them? Because they're doing their thinking for us, aren't they? They're doing a little bit of decision-making for us. So how can we trust them if we don't know how we think? So the value of what I've called the new model is these are the thought processes I'm trying to get bots to help. So if we understand how we think, we can understand what bots can do, what information those bots require, what decisions those bots can make legitimately, and what outputs those bots produce. And the way I'm beginning to think of these things is a bit like if your DevOps process is a little pieces of functionality distributed in your architecture, your software development architecture, it's a bit like the Internet of Things. Your DevOps processes become things on the Internet of Things. And I've got this hunch, it's only a hunch, that actually we'll be talking about software development as if it's an Internet of Things application in 10 years' time. It's a hunch. The question is, how do humans define what these bots do and what tools do, and when we hand over to them, how can we hand over responsibility safely? I think that's our challenge. Now, other people in your teams could do this, but I think the testers are best placed because business information, test information, communication of that information is our business. Okay? This is what we do. We are an information provision service. I think we're in the best position to do this stuff. Okay? So that's why you need to know how you think. So, okay, so next question is, will bots replace testers, or could we have a bot as a pair tester? Rather than a human partner, I have a bot as a partner, some software. Maybe I have an earpiece and it talks to me, and I talk to it. Maybe that's the way. Without spending much time on that, because I'm running out of time, I'm working on something to do this. So last week I was at Eurostar in Copenhagen, and I did a talk about what I'm doing with my invisible friend, which is my bot. Okay, it's very simple and basic. It's an experiment. It's like a concept car. It looks fantastic, but it doesn't work. Okay, that's what I'm doing back at home, if you like. But I think there's an opportunity to use a bot to support exploration, our thinking, and our testing. I think it's possible, okay? And that's about as far as I can go, because I just don't know anything more than that. I can't give you a live demo because I haven't got anything working yet, but I think it's possible. So testers need thinking tools, and we have hundreds of tools that support test execution. We've got them. That's not what we don't need more of them. Okay? Please tell people not to build them anymore. But if we have a thinking tool requirement, what is a requirement for a thinking tool? What sort of things do we have in mind here? Here we go. Discussing and debating requirements and their sources. Whose idea was this, to have the feature do that? Whose idea was that? You know, is a bot going to help you with that one? No. Identifying knowledge gaps, challenging sources, telling your users they need to think more carefully because their requirements are poor. Whatever. Deciding when a model is adequate or not adequate. That's a human thing. These are wicked problems. These are human problems, and I don't think bots are going to help us yet. In 5 years' time, 10 years' time, who knows? I don't know. But today, absolutely not. I wrote a paper last year called Will Robots Replace Testers? And I did a webinar for the Eurostar guys. It's about an hour long, so it's another hour of me, but it's me trying to defend that statement. Robots aren't going to replace us anytime soon. So the question is, will robots replace testers eventually? And my answer is, here he is, Terminator tester. Not yet, okay? Be aware. Now, pretty much everything I've said, you can see or read for yourselves in a little book. And I haven't got a copy in handy. But it's a book I wrote, but CA Technologies sponsored. And very nicely, they give them away if you ask for them. You've got to give a name and an email and that kind of crap. But if you register on their mailing list, you can get a free copy of the book. And it'll talk about the new model, DevOps, shift left, analytics, all sorts of other stuff, Internet of Things as well. Recommend it to you. Please ask for one, because if you ask for one from CA, they have to buy one from me, okay? Rather than me give them all away, I'd rather a corporation did that. And with that, I am done, and I'll thank you very much. Thank you.
Thank you very much, Paul. I'm waiting for the questions. Yes. In
no
the
questions,
Slido,
right?
please ask your questions in Slido. Good. So the first one is, what is your opinion about context-driven scholars like Bach is talking about critical stance towards certification schemes like the ISTQB and best practices for testing?
I would say they're entitled to their own opinions.
Okay. You know, as I'm representing...
Sorry, is that not an answer? I mean, do you want me to contradict them, or do you want me to support them? Is that the question? I don't know. But what is my opinion about context-driven scholars? Their critical stance. Yes, we should have a critical stance to everything. That's called critical thinking. Okay? I'm critical of the... I don't want to upset people who have put a lot of effort into taking the scheme to where it is now. Okay? I don't want to upset anybody. But I have to say, I was the first chair of the ICEB scheme in the UK, from which ultimately all the certifications derive. It's all my fault, right? My dispute is that it's not made as much progress as it should have done. If I put the syllabus from 20 years ago in front of you, you'd say, well, that's probably not far off what we've got today. It's not moved on. That's my criticism. I don't think certification is wrong. I think the certification we've got needs to work a bit harder on making progress. It needs to go faster, I would say. That's my criticism.
Thank you. The last one, or at least the next one, is Lloyd mentioned that managers only cares about the numbers, and you've been given 1 week for testing. How should we handle time if a method won't work? Any clues? Okay.
Yes, that's what my tutorial was about on Monday, partly. So Lloyd showed you his piece of paper, which I've kicked on the floor, right? And he tore it up. His model was a piece of paper with 4 weeks of testing. And he said, if you give me less time, that's what you get. You get less testing. That was his model, because that was a model, if you like, I don't think he'd do it with paper, I think he'd do it with a project plan and say, okay, we get squeezed, we get half the effort, half the resource, half the tests, half the everything. I would perhaps say, well, look at my test model. I've agreed a model with the business, which is their business process, and I'm going to traverse paths through that business process, covering decisions. And we've agreed with the business that we do 4 weeks testing to cover 48 test paths. I'm very happy if you cut me down to 2 weeks. I don't care. That's not my problem. But you're going to have a hell of a fight with the business. Off you go. It's not my battle to fight. Again, Lloyd said, pick your battles. That's not one testers should ever fight. If someone says we have no time for testing, I'll say, fine, let's go down the pub. It's not my problem to debate resources that are available for testing. I am that resource in that respect. So my model, the model I would use to argue would be my test model. Because I can use that to estimate, because I can identify the number of tests I need to cover it. And I've agreed that model, and that model is not my model. It's the business's model. Go and argue with them. It could be the programmer said, we need to test these interfaces, da-da-da-da-da. Well, the programmer has said, well, this is the technical architecture. You need tests that do all these checks on interfaces. Fine. Which ones don't you want to test, Mr. Project Manager? That's your problem. You need to debate that with the developer. I'm not being round shoulders. That's just not the battle we're here to fight. Okay? In fact, there are no battles in testing, are there? It's a bug. No, it's not a bug. I mean, that's not a battle. That's an opinion. All right? So yes, I have ideas. That's my idea. I would go, YNWA. What does that mean?
I have as much clue as you have.
Stephen Gerrard. Are we related? I might be related, but very, very distantly. I don't think so. But I am from Liverpool. Up the Reds!